Assalamu alaikum students. Today we are going to study about the refraction through prism. How prism is used to study the dispersion of light, refraction of light, and how it can be used in the phenomena of total internal reflection. So the learning objective of today's video is how light is deviated by a prism, how white light is dispersed by a prism, the colors of white light spectrum, and about the wavelength of different colors. Here is a glass prism, and a ray of white light arrives. This. And this ray of light, what will happen to it? See, it is mainly reflected or refracted. Both phenomena will occur, but it will mainly refract. Okay. Refract means it will, because prism is made up of transparent medium, it will enter the prism. Okay, and what will happen to it? How it will enter? Will it go? Will it continue moving in a straight line like this, or it will bend towards or away from the normal? It will bend towards the normal. See, this is the normal line. Dotted line shows normal. The ray is bending towards the normal, and different colors will deviate in different direction. Okay, it will bend through an angle and dispersed. It will split up into 7 separate colors. These, the upper one is the red, rest are in between, and the bottom one is the violet. This thing. So it means it bends twice. Once first it bends while entering the prism, and second time it bends while leaving the prism. First time it bends towards the normal, and second time it bends away from the normal, with red color deviating the least and violet color deviating the most. This is the screen. So on the screen you will see 7 colors on this. Okay, the patch of 7 colors will be obtained. We call it spectrum, band of 7 colors. Violet is deviated the most and red is deviated the least. This is the spectrum on the screen. This. Okay, so red, and this is orange, yellow, green, blue, indigo, and violet. So we also call it Roy G. Biv or Wib Geor if you start reading from violet color. What is the difference between red and violet light? Actually, all the colors have different frequency or wavelength. Okay, so this is about violet and its wavelength from crest to crest. You studied in your previous lessons about the wavelength and frequency, and this is the red one. The red one, the wavelength, like distance between two consecutive crests, is longer than the wavelength of violet. Here the violet 4 by 10,000 millimeter means 0.0004 millimeter is the wavelength of violet. And what about the red? It is 7 by 10,000, means longer. So now you should know what happens when white light enters a prism, and you can distinguish between deviation and dispersion, and know the colors of spectrum in order, and your connection between the wavelength and the color. Now you see here more about dispersion. Amount of refraction is different for each color. Single beam of white light can be split into rainbow of colors. Dispersion is the refraction actually of white light into seven colors. Here, one natural phenomena which is seen here, the rainbow color is seen after the rain. White light when the light enters the water droplets, these water droplets also act like a prism, and they will produce this band of seven color in the sky, which we call rainbow. Here, this is a detailed diagram of this rainbow. White light is striking a water droplet. Here it disperses into seven colors. You can see again here, the red deviates the least, and violet deviates the uh, most. There is one more phenomena, partial reflection and refraction. Refraction is often accompanied by reflection. It means whenever this happens, refraction occurs, the ray of light reflects also from the boundary. Here you can see the pond water here, reflection. Due to reflection, you see the sky in water, and due to refraction, you see fish through the water and the other underwater objects. Okay, they are seen due to refraction, and sky is seen due to reflection of light. Okay, so this is the ray diagram showing both reflection and refraction. The ray which strikes the air water boundary, part of the ray of light is reflected from the surface. Obeying the laws of reflection, angle of incidence is equal to angle of refraction, and remaining part enters. So this is angle of refraction here. Now we will study more about some prism. Prisms, they also work on the principle of total internal reflection. They are specially shaped prism. We call it 45, 45, 90-degree prism. So this prism, it at this side, hypotenuse side, the total internal reflection occurs because the ray is striking at an angle which is greater than the critical angle for the glass, and it is undergoing this total internal reflection, and it undergoes total internal reflection once again. Here we can draw this, and we can understand this how this happens. This is your total, this is the prism, and it is suppose 45, 45 and 90-degree prism. I can have one more diagram of this prism. Okay, so I have placed these two prisms in such a way that their hypotenuse sides are parallel to each other. So when a ray of light strikes this side, suppose this angle is 45, this is also 45, and this is 90. Okay, so here a ray of light is striking this way. Why this ray is not bending? First place, the first question which arises is what? Why a ray is not bending when it enters air to glass boundary? What is the reason? Because it's striking the air to glass boundary at 90-degree. Okay, so this ray goes straight without deviating. This is your air, and this is your glass. Now let us draw normal at the point of incidence. This is the point of incidence, P. Okay, so we will draw normal here. Normal will be at 90-degree to the surface, means this is the norm. If you apply this geometry, Here this angle will be 45. So this is also 45. Means ray of light is striking at an angle greater than the critical angle. And this was actually going from glass to air. This is glass and it was about to go from glass to air. But the angle at which it is striking the boundary of glass to air, this is air outside, that angle is more than the critical angle. Critical angle for the glass is 42. Critical angle for glass 42 means this angle is greater than our critical angle, so it will not enter the air, it will undergo total internal reflection, it will come back to the prism, same medium glass. Okay, now while leaving this again glass to air boundary, it does not deviate because again this angle is 90 degree. The ray is entering from glass to air at 90 degree to the boundary. Okay, so it goes undeviated. So here of the second prism, this is prism 1 and this is prism 2. So second prism also it goes straight because this angle is 90 degree. Now this is again 45, 90 degree prism, and if you draw the normal at the point of incidence here, this angle again will be 45. This was 45, so this is 45, this is 90, this means this is also 45. Again the ray is striking at an angle greater than the critical angle. So what will happen to this ray? It was here entering from, this is hypotenuse side of prism 2, it was entering into air. So because the angle is greater than the critical angle, so it won't enter the air, it will reflect back. Obeying the laws of reflection, it will undergo now total internal reflection and it goes this way. So due to this characteristic, we can get the image of any object from which the ray of light is coming. So we can have two rays striking the prism. Okay, we can have one more ray of light coming from an object. Okay, same way it will go, total internal reflection. Okay, so if human eye is there, so I can see the image of the object from where the ray is coming. Okay, suppose there is a candle or there is a anything, there may be a, suppose it is underwater, so there may be a ship coming approaching, so this can be seen. Okay, so this surface where total internal reflection takes place, which sides? Here side AB of this prism 1, and side CD of prism 2. They look like mirror because here reflection is taking place. Okay, so we can see the image of this ship when we look into this second prism. So image will be formed somewhere here and this side CD will be acting like a mirror. There is this is one diagram of totally reflecting prism. We also call it totally reflecting prism, and we have second one as well. This is one diagram which is 90-45 degree prism. This is another prism which is also showing total internal reflection. How it is showing total internal reflection? Ray A, it strikes the boundary of air to glass and here it bends towards the normal, and the point where it strikes, this is greater than the critical angle, so it undergoes total internal reflection and comes out of this. I can explain you in more detail about that prism. This one. Okay, here ray of light is striking. This ray A strikes this point. If you draw the normal here at this point, if you draw the normal at this point, it will bend towards the normal because it's going from air to glass. Okay, and here it strikes the side, other side of the prism. This is one side. You may label it like this is side P, Q, and this is side R. Okay, so when it strikes side PQ, it is going from air to glass, denser medium bends towards the normal. Now it strikes side PR. So here the ray is striking at an angle greater than the critical angle. So we can draw a normal here at this point again. Wherever the ray strikes the boundary, we can get the angle by drawing normal at that point of incidence. So this angle at which it is striking here, the side PR is greater than the critical angle. So here it is undergoing total internal reflection. Now again here this is leaving the glass, again medium is changed. So you can draw one more normal here at this point, and now it will bend away from the normal. You can see this is a ray which is going this way, and here it is leaving this glass and entering the air, so bending away from the normal. Same thing is happening with ray B. This was ray A, ray B, normal for this ray B, and it goes this way. And this is also called erecting prism, and we will study about the erecting prism when we will study about the lenses. So it can be used to invert the image. Suppose something is like this. Erecting prism means, sorry, something is upside down, so it will make it upright, or something upright, it will make it upside down. Because see, ray A is now the positions are changed. First ray A was up, B was down, now B is up and A is down. It means something, any pencil or any object like this is an object, for example. This is an object. How will this object appear? And these two rays A and B are coming from this object. This object will appear this way. Okay, so this will turn upside down. We call it erecting prism. Okay, in the same way, something is upside down, that will appear upright. Okay, so this prism is specially used with the lenses. So that's all for today, and inshallah we will come with the other video and new topic. Best of luck, and Allah Hafiz.